This is MYP5 Unit 4. It's the first of two videos covering probability. The first one should be mostly revision for you. And we're starting with either or probabilities. So thinking about the classic exam situation of different colour balls being picked from a bag, then the probability of yellow or blue is just the probability of yellow plus the probability of blue. So that's 3/6 plus 2/6 in this case, which is 5/6. And of course that makes perfect sense because 5 out of the 6 balls in the bag are either yellow or blue. So that's an example of mutually exclusive events. Yellow and blue are mutually exclusive events because there's no possible overlap between yellow and blue. You can't pick out a ball that is simultaneously yellow and also blue. So there's no overlap, they're mutually exclusive. But sometimes we have to deal with situations with non-mutually exclusive events. And that might be, for example, a deck of cards, and you're thinking about the probability of a 9 or a heart. Now, if you just try and add up the probability of a 9, which is 4 out of 52, plus the probability of a heart, which is 13 out of 52, then you end up counting the 9 of hearts twice, because the two events 9 and heart aren't mutually exclusive. There is a possible event that is both a 9 and also a heart. So because of that, we need to subtract the probability of the 9 of hearts, subtract 1 out of 52, so that we don't count that 9 of hearts twice. And generally speaking, we can write the probability of A union B, that's the probability of event A or B or both happening, is equal to the probability of event A plus the probability of event B minus the probability of A intersect B. That's minus the probability of the overlap event where A and B both happen, in the previous case 9 and hearts. Okay, now thinking about and also probabilities, this might be the situation where you take a ball out of a bag and then take another ball out of a bag. And there's two ways you can do that. You can take a ball out, replace it, and take another one out, or you can take it out without replacement. So we're starting with replacement. So at the start there's 3 possibilities in this case, red, yellow or blue, with probabilities of 1/6, 3/6 and 2/6 respectively. So once you've taken one ball out, let's say you take a red, you put it back, so there's still the same balls in the bag, so there's still the same 1/6, 3/6, 2/6 probabilities. Same if you pick a yellow first or if you pick a blue first. So the probabilities on the second level are exactly the same as before because we replaced the ball. We can now multiply these out. Remember, the key calculation for an and also probability is to multiply. So we can multiply these out to get the individual probabilities of each of the 9 different possible outcomes. So the chance of red is a 6th times a 6th, which is a 36th. The chance of red-yellow is 3/36, just by multiplying out the branches. Probability of red-blue is 2 out of 36. And you can calculate all of those, multiplying them out. And they should add up to 1, because we've covered all of the possibilities. So we're certain to get one of these, and something with a certain probability has a probability of 1. So you add up all of those probabilities and you do indeed get 36/36, otherwise known as 1. So that was with replacement, but more often in an exam situation you get without replacement, where you take a ball out and keep it out. In fact, that's the same as taking 2 balls out at the same time. I've got a bag of stuff here, so whether I take one out and keep it out, and then take another one out. That's exactly the same as just dipping my hand in and taking two at the same time. So if you see a question where you take two of something out, that's the same as taking them one after another without replacing them. So here's the probabilities. At the first level, it's red, yellow, blue, a sixth, 3/6, and 2/6, just as before. But think about the case where we've taken a red out. Once we've done that, there are fewer reds in the bag and fewer balls in the bag. So the probability of a red on the second pick is 0 out of 5, because there's only 5 balls left, and in fact none of them are red because we took one out. The chance of a yellow is 3 out of 5 because there's 3 yellows left out of 5, and the chance of a blue is 2 out of 5. So that's the case where we took a red. Now the case where we took a yellow. This time there is 1 fewer yellow in the bag out of only 5 now. So the probabilities become 1/5 for a red, 2/5 for a yellow only, and 2/5 for a blue. And then finally, in the case where we took a blue first, there are only 5 balls left and 1 blue fewer. So the probabilities for red, yellow, and blue become 1/5, 3/5, and 1/5 respectively. If we now multiply those out to see the combined probabilities of various things, well, the chance of a red then a red is 0, and that makes sense because you can't get 2 reds when there's only 1 in the bag. Chance of red yellow is 3/30. Chance of red blue is 2/30. Yellow red 3/30. Yellow yellow 6/30. Yellow blue 6/30. Blue red 2/30. Blue yellow 6/30. And finally blue blue 2/30. And again, that covers all of the possibilities. So if you add all of those up, you will find they come to 30/30, otherwise known as 1. So let's have a look at the probability of exactly 1 yellow. You might get an exam question like this, and the tree diagram is quite helpful there because you can identify on the tree diagram all the different ways of getting exactly 1 yellow. So that could be red yellow, yellow red, yellow blue, or blue yellow. So you can just identify those, add them up, and the probability of exactly 1 yellow comes to 18/30, which you can simplify if you want. So that was one type of problem. I'm now going to look at least probabilities, where they ask you what is the probability of getting at least 1 red or yellow or blue. I've simplified the diagram in this case, and now I'm just thinking about yellow or not yellow. So the probability of a yellow is 3/6. The probability of not yellow is 3/6. Looking at the numbers of balls in the bag. Y dash, that means not yellow. Then on the second level, because it's without replacement and we've taken one out, the probability, if we took a yellow first, the probability of a yellow then becomes 2/5, and not a yellow becomes 3/5, because there would only be 2 yellows and 3 non-yellows out of 5 left in the bag. But in the case where we didn't take a yellow first, then there's 3 yellows and 2 non-yellows in the bag, so the probabilities are 3/5 and 2/5 respectively. So we multiply those out to get the various probabilities of different outcomes: yellow, 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 not yellow, not yellow, yellow, or not yellow, not yellow. And we can work out the probability of at least 1 yellow. And there's a smart way to do this and a not so smart way to do this. So the not so smart way to do this is to identify all of them. So that's 6/30 plus 9/30 plus 9/30, which comes to 24/30. Now that was quite easy just with 2 picks, but it could have been 3 picks with 8 possibilities at the end, or 4 picks with 16 possibilities at the end. So with lots of picks, that could become quite a long calculation. But if you do it the smart way, you can say the probability of at least 1 yellow is 1 minus the probability of no yellows at all, because it's either got to be at least one yellow or none at all. So those probabilities have got to add up to 1. So the probability of at least one yellow is 1 minus the probability of no yellows at all. And then we've only got to subtract one thing, because the probability of no yellows at all is just the single event where we get not a yellow and not a yellow. So that's 1 minus 6/30, which again is 24/30. Now imagine if that was 4 picks, so that you'd have had a tree diagram with 16 things at the end. So that would have been a choice between adding up 15 different probabilities where you got at least one yellow, or just doing 1 minus the single probability where you don't. So calculating an at least probability as 1 minus something can make your life a lot easier.